Hi, I'm Rich with insideHPC. We're here at PASC 16 in Lausanne, Switzerland. And I'm here with, how do I say your name? Dimosthenis?
It's Dimosthenis.
Dimosthenis. Ah, okay. And you have a poster about CFD. Can you tell me more about it?
Yes, it's a poster that was motivated by the benchmark from Turek and Schäfer, a work in 1996. They were estimating drag and lift coefficients. And we thought that maybe we can find a meaningful behavior of those coefficients if we change the roughness on the material. If we start estimating true materials, because there is roughness in nature. We tried to do that, and we got some meaningful results. So we're working with Newtonian fluids. It's an incompressible steady state flow. And we also use a really interesting software for our work. It's called Phoenix. We employed some adaptive mesh refinement techniques. And a crucial part of our work was the fact that we were able to use a CSCS pitch-Dane supercomputer to run our simulations.
Okay. Now, are you able to use wind tunnels at all to verify this, or what did you do?
There was an issue there that we couldn't find experimental data, and the data with which we are comparing is data from other simulations that were performed. We tried to simulate wind tunnel effects, where wind tunnel effect is an effect where the domain passes through the cylinder. Okay, we tried to simulate this, but for that we couldn't find neither literature or simulation data. So in the end, we stick with a domain where we have an inflow, a parabolic inflow, that crashes on our cylinder.
Yeah.
We estimate on the cylinder the drag and lift, and then there is an outflow after a small amount of time.
Okay. So you think just that the texture on the surface of whatever you're measuring makes a difference?
Yeah, it makes. We can take a brief look here.
Yeah.
And this makes sense. You know, the roughness scale is increasing, and the drag coefficient, which I think we should imagine as the friction.
Yes.
In a sense.
Yes.
Okay. The more rough the material is, the more friction we have. It makes sense.
Right.
So it makes sense. I was happy when I saw it.
Yeah, like carpet, right?
Yeah.
Something. Yes. Okay.
Big roughness, big friction.
Yeah.
Easy.
All right. So is this your first time at the PASC conference here?
Yeah, it's the first time at the PASC conference.
Did you find it valuable? Was it good for you?
You know, it was actually quite cool.
Yeah.
I'm doing my master right now, so it was interesting to see, I don't know, a really scientific environment, ongoing work.
Yeah.
Okay, ongoing work in many fields.
Yeah.
Especially the fluid symposiums that I attended were. It was nice. It was nice.
Okay. Well, hey, thanks for sharing that with us. Good job.